Hello guys, a very good morning everyone. Good morning to all the ISRO champions, all the ISRO aspirants. This is Rakesh Talreja and I welcome you all to BYJU'S exam prep. Yes, guys. So ISRO exam is just 1 week ahead, and you must have prepared a lot for this examination. But as you know, some of the important topics, if by chance you have missed or if you need more practice, especially those which are repeatedly asked, like last week I took the session on microprocessor, because especially microprocessor is an area which is not in the gate also these days. So you have to study that separately, and then some other important areas step by step we are trying to focus. Okay, and today we are going to have the important question practice session on the antenna theory, right? The important question practice session on the antenna theory we are going to have today, right? As you again must be knowing, antenna is a crucial topic because questions are expected from this area. Okay, so let's get started with the antenna, the discussions of the antenna, right? The important questions on antenna. Let's get started. This is a regular introduction. Let's get moving ahead. Here it is. So, the BYJU'S exam prep students in the Engineering Services 2023 conducted by UPSC have really outshined with 5 students under rank 10, AIR 1, Vineet Jain, AIR 9, Varun Kumar, 29 under rank 50, 37 under rank 100. Okay, we just hope and pray with the same dedication and hard work you prepare and keep using BYJU'S exam prep app and the classes, you get meritorious results like this. And now let's get moving ahead with the first question for the day. Okay, a small current element has the length lambda by 25, the radiation resistance. The first important category, the first important category of question that comes up from antenna is the radiation resistance, very much expected type. Okay, very much expected type. Okay, good morning all, keep joining, very good morning. Okay, keep joining, keep sharing the session. Hanji, bataiye. Okay, so this small current element has the length lambda by 25. What is the radiation resistance for this? Okay, so first of all, okay, the length, it's a very small length. Let's call it as DL, and that is given to you as lambda by 25. And then this DL, okay, is it less than lambda by 10? Whenever the length is small, okay, let's say, 10% of the wavelength here, smaller than that, that is known as that concept, that small current element is known as what? The Hertzian dipole. Okay, this comes under the case of Hertzian dipole. Okay, the Hertzian dipole element. And for the Hertzian dipole element, what is the radiation resistance? For the Hertzian dipole element, the radiation resistance is given by 80 pi square dl by lambda whole square. Sorry, dl by lambda whole square. Okay, so just put down this value. I get the radiation resistance. Okay, pi square के form में ही रखना है, so only basic simplification is required here. DL, the small length is lambda by 25, lambda को cancel करेंगे तो 1/25 का square, so that looks like 80 pi square by 625, cancelable only with 5, so 16 pi square by 125. Here we have option number B, all of you guys, option number B. Done hai ji? Correct answer, Ankit Kumar. Yes, option number B it is. Next question, dear. The radiation resistance of a thin wire center fed lambda by 2 antenna. Okay, length. Okay, now it's not that small, it's lambda by 2. Okay, half of the wavelength. Okay, and such a dipole element is known as what? This is the half wave dipole. The small dipole element is known as the Hertzian dipole. Okay, for the length lambda by 2. Okay, it's half wave dipole. Okay. For short dipole, isn't it same? What same? What parameter same you're looking for, Ankit Kumar? Please, can you specify? Okay. So, this is a half wave dipole, and since the length is fixed, of course, it has a fixed radiation resistance. How much? Okay, it has a fixed radiation resistance. Only R rad. Okay. For the half wave dipole has the fixed value, that is the 73 ohm. That is the 73 ohm. Correct answer. Yes, correct, Kumar. Correct answer. You must know this. Very standard result. You must know this. Okay, you must know this. Okay. If they ask the impedance, complete impedance. Okay, complete impedance. Okay. Then that complete impedance. Okay. Okay, the input impedance is Rn plus Jxn. Okay, where Rn is for the lossless antenna given by R rad only, and that is 73 and X in calculated value is 42.5. Then it is B if they ask the complete input impedance, but the radiation resistance, if they ask only resistance part, that is the 73 ohm. Clear? Yes, Ankit Kumar. ठीक है जी, done है. Okay. अच्छा, if this is the lambda by 2 dipole. Okay, what about a lambda by 4 monopole? Quarter wave monopole. Standard values to remember. If it is a quarter wave monopole, why we call it as monopole, dear? Its resistance is half of what you have previously seen, 73 by 2. That is 73 by 2. Okay. And that is 36.5 ohms. Okay, we call it as monopole because unlike dipole, it is only a single element, okay, a single pole located above a ground plane, located about a infinite grounded plane. Okay, a lambda by 4 monopole located above a conducting ground plane. And whenever there is a concept related with conducting ground plane, we apply method of images and solve the problems. But yeah, these are the values which are solved and given in front of you. 36.5. 36.5. Nana Ankit, for Hertzian, it depends on length. It is not same. It is 80 pi square dl by lambda. It is always proportional to the lambda. It is always proportional to the square of the length. ठीक है जी. Next question, dear. ये हो गया. A mast antenna consisting of a 50-meter long vertical conductor operates over, okay, here it is, what I was talking about. Okay, it's a 50-meter long antenna operating over a perfectly conducting ground plane. Perfectly conducting ground plane. Okay, it is base fed at a frequency of 600 kilohertz. Okay, now first of all, how much is the length? How much is the length? Okay, the frequency is given to me as 600 kilohertz. So lambda निकालेंगे. Lambda we know we can calculate as C by 8, 3 into 10 power 8 divided by frequency 600 kilo, that is 610 power 3. Okay, so ये हो गया 3000 by 6, that looks like 500. Is it okay? Okay, 10 power 5 cancel हुआ ना, या तो 3000 by 6, 500. Okay, so the wavelength here is 500 meter and the length that is given to you. The length that has been given to you, dear. Okay, the length, okay, is given to you, or let me call it as DL, that is 50 meter and that is precisely lambda by 10. So we can think about Hertzian. We can think about a Hertzian. But is it a Hertzian dipole? Okay, it's only a long vertical conductor which is operating over a perfectly conducting ground plane. Okay, which is operating above a perfectly conducting ground plane. Okay, infinite ground plane. Okay. Now we know when there is a ground plane, we apply method of images, and ultimately when you try to solve the problem, you remove this, you apply method of images, image source will come, and that ultimately gives a picture of dipole. But to solve it, we make dipole, but ultimately it's a monopole. Those who have studied antenna with full derivations, you must be knowing this point. But yeah, right now, what is the conclusion? We can call it as the case of Hertzian monopole. We can call it as the case of Hertzian monopole because, okay, it's a single pole operating above a conducting ground plane. And what is the radiation resistance? In that case, dear, it is half of that of dipole. Okay, 40 pi square dl by lambda whole square. 40 pi square dl by lambda whole square. Okay. 40 pi square, half of dipole always. So now this time it is going to be 40 pi square dl. Length is 50. Wavelength is 500. And then whole square, so this is gonna be 40 pi square divided by 10 to 10 square 100, and that is 0.4 pi square, 2 by 5 in terms of fractional. The option is given, the 2 by 5 square, option number A. Correct hai ji? Option number A. Get it? Any doubt, please ask me. No, we consider image while deriving it. Definitely, Kumar. Okay, we consider the image while deriving it. Okay, but why the radiation resistance is half, Kumar? Because, of course, image. Okay, the image of the source is taken to solve the problem, but actually there is only a single source. Okay, radiating above a infinite ground plane. So radiation is only in the upper hemisphere. Okay, if there was no grounded plane, the radiation of the antenna is usually in all directions, spherical direction. Okay, but when the source is placed above an infinite grounded plane, it can only radiate above that ground in the hemispherical portion. And that is why the radiation resistance, radiated power is 50% of what a dipole can produce. Okay, chalo, next question. A dipole with a length of 1.5 meter operates at 100 megahertz, while the other has a length of 15 meter and operates at 10 megahertz. The dipoles are fed with the same current. The power radiated by two antenna. The question is going to be talking about power radiated, and both are fed with the same current. Both are basically fed with the same current. Chalo. Both are fed with the same current. ठीक है जी, चलो. Okay, so what is the power, radiated power? Okay, radiated power compare करना है, and how do you calculate the radiated power? It is given by half I naught square R rad. Okay, and both are fed with the same current. Okay, so amplitude of the current I naught will be same for both. That is what I can say. Okay, so radiated power will be more if radiation resistance is more. That's what we need. Okay, because I naught to same hai. Okay, radiation resistance, let's see for both of them. Okay, case number one. Okay, case number one. Okay, there is a length of 1.5 and the frequency is 100 megahertz. So what is the lambda first of all? Okay, length to be compared with lambda. Then we decide whether it is half-wave dipole, whether it is Hertzian dipole or what it is. Okay, so lambda is given by C by F, 3 into 10 power 8 divided by the operating frequency. First is 100 megahertz. 100 into 10 power 6. So pura 10 power 8 cancelled. Lambda is 3 meters. Okay, so length is equal to how much? Length is equal to 1.5 meters given hai, and that is lambda by 2. Okay, ये lambda by 2 है, तो radiation resistance is equal to 73 ohms. Okay, case number 2, what is the wavelength? Operating wavelength C by F, 3 into 10 power 8 divided by the frequency, and the next case frequency is 10 megahertz. Okay, so this is 10 power 7 only cancelled, and the wavelength is 30 meters. So length is gonna be given by how much? Length of 15 meter. Okay, length is 15 meter given hai, and this is again lambda by 2. This is again lambda by 2, and accordingly what is the radiation resistance here? 73 ohms. Okay, so ultimately radiation resistance also turns out to be the same for both. Okay. Okay, if everything is same, the radiated power also remains to be same in both the case because they are fed with the same current. Is it okay, everybody? Okay, so the correct answer is option number B. Both antennas radiate the same power. Both the antennas radiate the same power. Okay, ji. Okay. Okay, let's get moving ahead to the next question then. An antenna has a radiation resistance of 72, a loss resistance of 8, and a power gain of 16. Calculate the directive gain. Now, this is gonna be on the efficiency eta R, radiation efficiency. Okay, this is going to talk about the radiation efficiency. Now, there are multiple ways of defining the radiation efficiency. You must remember all this formula. This eta, simply, you can call it as eta also. Okay, why I am reading eta R? Because there are two efficiency that we define with antenna. One is the aperture efficiency. Okay, one is the aperture efficiency. Okay. That depends na what current value you're taking, whether you're taking the RMS value or whether you're taking the peak value, Kumar. The same thing that you apply in the networks and other cases also. So I've taken I naught as the peak current. That is why half I square R. If you want, you can take with the RMS value. Okay. So then you only take I square R. ठीक है जी? So eta, now what are the formulas for eta? You must remember. Okay, eta is given by GP upon GD, where GP is the power gain, GD is the directive gain. Okay, it is also given by the radiated. See, it is the power radiated by the antenna divided by the power that is the input to the antenna. Okay, there is some power input to the antenna. Okay, and a part of it is radiated. Okay, so that input power is also broken as some part is radiated and some part is lost. Some part is lost due to the conductors of the antenna, conductor skin effect. Okay, so some part is lost. Okay, conductor losses or ohmic losses isko bolte hain. Okay, and the remaining part is radiated. The total radiated power plus lost power is the input power. Okay, that is what supplied to the antenna. So what is supplied to the antenna and how much it is radiating to the free space, that is what is the efficiency. Again, writing power is equal to half I square R. The formula also comes in terms of R rad. Half I square cancel karte hue, R rad upon R rad is divided by R rad upon RL, where RL is the loss resistance. Where RL is known as the loss resistance. ठीक है जी? So you must please note down this one. Okay. Radiation resistance given hai. Okay. So one thing that is given is R rad. Loss resistance, that is what I'm telling you, RL. Okay, power gain given hai. That power gain here is coming up as GP. You need to calculate the power gain, directive gain, that is the GD. Clear? These are the different terms. Okay, so we can just compare. Efficiency given to nahi hai, we can just compare these two terms and get hold of the answer. Okay, so I would have efficiency. I'll use this formula. GP by GD is equal to R rad upon radiation resistance wala formula. R rad upon R rad plus RL. Okay, power gain is 16, correct hai. Directive gain is to be required is equal to radiation resistance 72 upon 72 plus loss resistance, that is 8. Okay, so what is the value for GD? It is 16 is multiplied by this is 80 divided by 72. Okay, so it's like 16 is 8 se cancel kare, that is 10 by 9. This one is 160 divided by 9. Okay, 160 is divided by the 9. So how much it will be? 17 and then 7 by 9, the 0.7, 17.77. Yeah, 17.78. Just check out once. 17.78 होना चाहिए, ठीक है? Yeah, correct. 17.78. So correct answer is here in front of us. That is option number C. Okay, recheck the calculations once, Kumar. Correct. Yes, Ankit Kumar and Meghna. Correct answer now. Answer is option number C. Answer is option number C. Next question ready for you. A person with a receiver is 5 km away from the transmitter. Okay. What is the distance that this person must move further to detect a 3 dB decrease in the signal strength? Okay, in the signal strength. Dekho, the signal strength for any antenna in the far field is always proportional to 1 by R. It's a simple logical question. For any antenna in the far field, the strength is inversely proportional to the distance from the antenna. Okay, proportional to 1 by R simply. Okay, so that now you want a 3 dB decrease. Achha, it is given in decibel. It is given in decibel. Now we know how do we write down in decibel. What is given to you is 20 log. Okay, 20 log E2 upon E1 will be minus 3 dB. 3 dB decrease hai na? So that is minus 3 dB. Minus 3 dB. Okay, so when you solve this, Nadir, what is going to be E2 by E1? Okay, 3 by 20 and then you take the 10 power. Okay. Yeah, this is gonna be 1 by root 2 basically. Okay, E2 by E1 is 1 by root 2. Okay, in the absolute form if I want to calculate. Okay, now the person, देखो E2 by E1 पता चल गया, and this E2 by E1, now let's bring here, E2 by E1 should be equal to, because of inverse relation, should be R1 by R2, and that is 1 by root 2. Okay, so R1, the first distance is 5. What should be the second distance? R1 into root 2. Okay, so that should be 5 root 2. Okay, 5 root 2 approximately will turn out to be 7.07 kilometer. Okay, now what distance he must move? R2 is the second distance. Initially he is at 5 kilometer. Now he should be at the 7.07 kilometer. So what is the distance to be moved? And that is 2.07 kilometer. 2.07 kilometer or 2070 meter. Answer is B. 2070 meter. Answer is B. Answer is B. Okay, next question done. Determine the electric field intensity, again on the field intensity, at a distance of 10 km from an antenna having the directive gain of 5 and radiating a total power of 20 kilowatt. Okay, now having the directive gain, again a question relating directive gain. Okay, radiating a total power P rad given hai yahan pe. Okay, distance is given to be as 10. Now what is the directive gain? See, once we have used this in the efficiency. Okay, but what is the basic formula for the directive gain? Okay, let us revise this very important formula. GD theta phi. What is this GD theta phi? the GD theta phi is given by U theta phi upon U average. Now what is this U theta phi? This is known as radiation intensity, okay, divided by average radiation intensity. This is known as the average value of average radiation intensity. Radiation intensity divided by the average radiation intensity. Okay. Now what is the radiation intensity? Okay, radiation intensity is further given by the formula R square P average. Okay, where P average is the power density pointing vector, the power density associated with the wave. Average radiation intensity turns out to be the power radiated by the antenna divided by 4 pi. Sabka individual formulation also you must know. Okay, so in that case, we can now tell that the final formula for GD, okay, U theta R square P average, okay, divided by U average, that is P rad upon 4 pi. P rad upon 4 pi, so I shift the 4 pi in the numerator, and that is one very common important formula for GD. 4 pi R square P average upon P rad. 4 pi R square P rad upon P average upon P rad. So first let us calculate P average, and that will be given by GD. GD given hai, acha, that is 5 dB. Ye bhi dekh lenge yahan pe. Okay, so what is given to you is logarithm value, and since it is a gain value, we'll write it in 10 log. It is not the magnitude value. So 10 log GD is 5. GD will be 10 raised to the power 5 by 10, that is 0.5. Basically under root of 10 हुआ ये 3.16. So absolute value of GD is 3.16. Absolute value कितना हुआ 3.16. So 3.16 into radiated power. What is the radiated power? 20 kilowatt. 20 into 10 power 3 is divided by 4 pi R square. What is the value of R? Distance is 10 kilometer. 10 kilometer, so 10 into 10 power 3 whole square. Okay guys, so let's calculate this number quickly. And that is going to be 10 power 4, 10 power 8. Okay, so this is turning out to be nearly 5.03 into 10 raised to the power minus 5, and power density term hai, so that is given by watt per square meter. Power density given in the form of watt per square meter. That is the P average. Clear? That is known as the P average. Acha ji. Okay. Now they are asking the field intensity. Okay. Field intensity. Now pointing vector formula. Pointing vector formula. Okay. What is the pointing vector? Lossless medium assuming free, because free space transmission hai. Okay. The P average is mod E square by 2 eta. Okay, mod E square by 2 eta is 5.03 10 power minus 5. What is the value of mod E? From here we need the field strength. Eta will be 377 ohm free space ke liye. Okay, so let's take down that answer. And after taking the under root and everything, 0.195. Solving the complete value, 0.195 volt per meter. 0.195 volt per meter. Find the last answer. That is a 0.195 volt per meter. Chalo, next question. A certain antenna with an efficiency of 95% has maximum radiation intensity 0.5 watt per steradian. Okay, and what is the directivity? Now, what is directivity? The next term that you will revise here today, it is the directivity D, and that is known as the maximum value of the directive gain. That is known as the maximum value of the directive gain. This is known as GD max. Okay, now what should be GD max? As I told you already, GD is given by U upon U average. Okay, u upon u average, or that is u average is what? P rad upon 4 pi. And then u is r square p average, but don't write down here r square p average, just write down this much. GD is u upon p rad. Now I want to maximize the GD. Directivity is GD max. And to maximize this, I should have the maximum radiation intensity. Okay. So that will become 4 pi u max upon p rad. And here the maximum radiation intensity is given. एक तो efficiency given है, and दूसरा given है maximum radiation intensity of 0.5. So that is the specified term 0.5, and then divided by p rad. So this becomes the 2 pi is divided by p rad. The 2 pi is divided by the p rad. ठीक है जी? The 2 pi is divided by the p rad. Okay, done. Fantastic. Now directivity के लिए what is needed is p rad, and there in the second question को देखेंगे, p rad is directly given. First question में थोड़ा सा effort मारेंगे, तो if I go with the B part first, in the B part P rad is directly given to me. The power radiated by the antenna is 0.3. Okay, so what is the directivity? 2 pi divided by P rad. Okay, divided by 0.3. Okay, so what's gonna be the answer? 20.94. Okay, and option number A पे आ जाएंगे. Okay, the input power. Okay, what is given in option number A? Input power, not the radiated power, and that is 0.54 watt given to me. Okay, so what is going to be the radiated power? Their efficiency will be used. Okay, efficiency given है ना 90%, 90 or 95, 95%, and we know that, as I already explained, your efficiency is the power radiated by the antenna divided by the power input to the antenna, and that is 95%, that is 0.95. So यहाँ से निकाल लीजिए ना, what is the power radiated to the antenna? Okay, input power is 0.4 into 0.95. 95% of this will be 38, that is 0.38 watts. Okay, and now the directivity hence will become 2 pi upon this radiated power. Okay, 2 pi upon this radiated power, 16.53. Okay, directivity will be 16.53 in the next case. Okay, the first answer is 16.53, second answer is 20.94. Okay, second wala pehle solve kiya tha, because in that second one the radiated power is directly given to me. Is that okay, dear? Yes, very, very good morning all. And now let's go ahead to the next question. Okay, let's go ahead to the next question. Indeed, one very, very important type of question across all competitive exam, whether you talk about ISRO or GATE or engineering services or any other exam. Okay, the radiation intensity, because this has some good calculations to be dealt with. The radiation intensity is given, the function, the radiation intensity U as a function of theta phi is given to you 2 sin theta sin phi. Okay, for theta is 0 to pi, phi is 0 se pi. Okay. So theta the full range given है, phi is only half range, because the complete range of phi is 0 से 2 pi, and it is 0 otherwise. What is the directivity? Again the question is on directivity. Directivity is the maximum directive gain. Okay, so I need the maximum directive gain. Yes, as of now I think ISRO hall tickets or admit cards are not released. Okay, and maybe I am hoping positive, you also hope positive, maybe the exam date may be shuffled because of the crash with Bell, but unless and until any announcement come up, don't take it as an assumption. You keep preparing hard for whatever exam you're targeting, because ultimately preparation is common for both na. Consider to करना चाहिए, because consider to करना चाहिए, because ultimately both are what? Okay, ultimately both are on the same day, both are for engineers. Okay, students have paid the fees for both, so they might consider. So let's wait, Abrar. So now up to weekend aa gaya, maybe we get some update on Monday or so. Chalo, aa jate. So directivity is maximum directive gain, and directive gain, the first focus on the directive gain. Okay, that depends on you. Okay, let's start with the GD. Directivity, again let me write down, it is the GD max. Okay, now let me start the GD calculation, and GD, as I told you, is given by U upon U average. Okay, and that will be further given by U averages P rad upon 4 pi. तो 4 pi को ऊपर कर दिया, this is 4 pi U divided by the P rad. ठीक है जी, ठीक है जी. Now U is given to me, but P rad is not given to me. Na? U to given hai. What is P rad? So here major focus will be finding the radiated power. Chalo. So let us calculate that radiated power. Okay, radiated power. How do we calculate this radiated power? Power, how do you calculate the power associated with any wave? It is the surface integral of the pointing vector. It is basically given by P average dot ds. एकदम basic से समझते हैं. It is given by the surface integral of the power density vector. Power density vector means pointing vector. Okay, now the pointing vector P average, whether it is given or not, वो देखते हैं. Okay, but when you take the ds, देखो, pointing vector is always in the radial direction, because how is the power radiated by antenna? In across all directions like a sphere. Okay, if this is an antenna source, it is going to radiate the power in all directions across it, radial direction. Okay, so P average is in radial direction, and what is the ds? In the radial direction, because the radiated power is along AR. So along AR, what is the ds? ds spherical coordinate system I will be using, and that is given by r square sine theta d phi along the radial direction. Okay, so when you take the dot product of both, okay, AR dot AR को 1 लिखेंगे, and then you are left with P average r square sine theta d phi. Let me write this once again. Okay. The power radiated by the antenna is then given by the double integral r square P average sine theta d phi. And here, this r square P average, this is what is the radiation intensity, na? This is what is the radiation intensity, I already told you. And this is known as the differential solid angle d omega, where omega is the solid angle, okay, the three-dimensional solid angle, and we write down this formula as U d omega, in short, U d omega. Now, the main thing is U is given to you. Okay, U has been given to you. So, what is the radiation power? What is the value of U? 2 sine theta sine phi. 2 sine theta sine phi. That is the U. Okay, and then d omega. That means sine theta d phi. Okay, now better, because both the limits are constant. Okay, what are the limit of theta? 0 se pi. What is the limit of phi? That is also 0 se pi. Whenever both the variable limit is just constant number, and if variables are separable, we separate them. Okay, like sine square theta is a different function, sine phi is different, we can separate. क्योंकि यहाँ पे हो रहा है, not every time you can separate. Okay, so here, first of all, 2 is constant. Okay, sine square theta separate, sine square theta d theta, sine phi d phi separate. Let's solve this separately. And what is sine square theta? What is the sine square theta? Okay, limit है 0 से pi. Theta limit also 0 से pi. Phi limit also 0 से pi. Okay, sine square theta can be integrated as 1 minus cos 2 theta divided by 2 d theta, or by the Wallis integral formula. Okay, so now one of the two is getting cancelled. Okay, so I have now 1 ka integral theta minus cos 2 theta integral will be sine 2 theta by 2, limit 0 se pi. Then integral sine phi minus cos phi 0 se pi. Okay, solve it up, guys. Okay, देखो sine 2 theta. Okay, तो sine 2 pi या sine 0 both is 0, तो limit बचेगा सिर्फ theta पे. तो first term should be pi minus 0. Okay, second one minus. Okay, minus के साथ cos pi is minus 1. Okay, cos 0 is 1, तो upper minus lower limit. ये हो गया total minus 2 of minus 2. The total answer should be 2 pi for the radiated power. Clear? Yes, Kumar, you can also go by Wallis integral formula. Okay. ठीक है. Chalo, so what is the radiated power is obtained as 2 pi. So now let's come to the GD calculation finally. What is the GD calculation then? As we have written it as 4 pi u divided by p rad. Now let's put down the value. 4 pi u is again 2 sine theta sine phi divided by radiated power is 2 pi. Okay, so final GD. See guys, sometimes they can only ask the directive gain function. Okay, so ये हो गया to cancel 4 sine theta sine phi. Okay, 0 less than theta less than phi 0 less than phi less than pi. Matlab both are 0 to pi. This is the GD function. If they ask the directive gain as a function. If they ask the directive gain as the function. Okay, यहाँ पे बोला है डायरेक्टिविटी बता दीजिए. So that is the maximum value of directive gain. What is the maximum value of sin theta or sin phi? Both are 1. They occur at pi by 2. So you should check whether the pi by 2 is in the allowed range. Yes. Okay. Okay. So both pi by 2 is in the allowed range. So sin theta, both of them will be maximized as 1. And the final maximum answer for the directivity will be 4. Answer should be the 4. Okay. Decibel mein pucha hai? No problem. Okay. In decibel, this becomes 10 log 4. 10 log 4 is just 20 log 2. That is going to be 6 dB. 6 dB. No, not 4 dB. It should be 6 dB. Check it out. Answer is option number B. Fourth absolute value and dB it is the 6. ठीक है जी. In the dB it is going to be 6. Just a second here. Chalte. Okay, let's move ahead towards the next question then. So these are all very, very good and important questions. Okay, yeah. So let's move ahead to the next 10. Okay, so before the next, the important update for you that yes, tomorrow 10th of December starting 9 AM. Okay, BYJU'S exam prep brings to you the next national scholarship test. Okay, appear in it and you can get as much as up to 90% scholarship on the GATE preparation courses and take a big step towards success in GATE examination. Okay, by using the courses of BYJU'S exam prep. And for those who are preparing for GATE 2025 and especially preparing along with college and job, you know, okay, most of the toppers of GATE are college going students only. But if you are finding difficulty, how can you manage the time with college or if you are having the job? Okay, so what are the time management fundas? I also got my All India rank 9 when I was a college going student, so it is quite possible. Okay, what are those fundas? Let's learn in this free live interactive workshop this Wednesday 7:30 PM. Okay, this Wednesday 7:30 PM. Okay, so both of the events are available on the app. Okay, if you want to download the app, just go to the description of the video. You will find the link. You can directly download the BYJU'S exam prep app. Okay. Right, and now as I told you, if you really excel in scholarship test, okay, you can enroll into the courses. So what are the current courses available? If you are a 2024 aspirant, GATE 24 crash course is available for the quick syllabus revision along with question practice. Okay, and the detailed courses for 2025 and 26 years, GATE 25 and GATE 26 available in both English and Hindi format. So you can choose language also of your comfort, and also these classes will offer you live classes with the facility of recorded lectures, also study material, mock tests, practice quizzes, everything to get you exam ready. In case of still any doubt, you can contact 924-16666 and get your doubts rectified. Next question पे आ जाते हैं. The gain of a parabolic dish antenna. So even in this ISRO exam, the questions on parabolic antenna are very, very common. Okay, the gain of a parabolic dish antenna of 1 meter diameter and 80% efficiency at 9.5 gigahertz. See, when I say gain, it would by default mean the power gain of the antenna. If nothing is mentioned, so gain with, you'll take it as the power gain. Okay, now diameter is given to you as 1 meter and 80% efficiency is given to you. Frequency 9.5 gigahertz. First of all, efficiency is GP upon GD, and there is the formula for effective area for the parabolic antenna. Okay, first of all, what is the in general formula for effective area of any antenna? AE is a term which is known as the effective area, and that is given by the formula lambda square by 4 pi into the GD. 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 That is the formula for effective area of an antenna. Okay. Now, effective area especially for parabolic dish antenna, it is given by The maximum effective area for parabolic antenna is pi r square, and r will be taken as diameter by 2. Okay, so we simply write it as pi d square by 4. Okay, that is the pi d square by 4. So let's start calculating now. Okay, so by the effective area, which is pi d square by 4, and that effective area is also equal to lambda square by 4 pi into the GD. I should be getting the value for GD first of all. The 4 is cancelled, but pi on the left side, pi square d square upon lambda square. Acha, that is pi d upon lambda ka whole square. But what is lambda? Lambda is not given, frequency is given. Okay, frequency is given. Okay, so C by F likh diya. So F pi FD upon C ka whole square. Let's put down the numbers and get the value for GD. Okay, acha. Then we also know, एक बार ही calculation करेंगे. GP upon GD is the efficiency, and that efficiency is 80% given. Am I correct? 0.8, right? So what is the power gain? That is 0.8 times GD, 0.8 times pi into F. Frequency is 9.5 giga. Okay, into D. What is the value of D? 1 meter. Divided by C. Okay, 3 into 10 power 8 का whole square. ठीक है, डन है. Okay, rest all is okay. हाँ, so just calculations dear. Okay, let's calculate this value. 10 power 9, 10 power 8, it's only 10. Then take up the square and into 0.8. I am getting it as 7917. 7917.6. Okay, of course it is in dB. Okay, so if you take the 10 log of this, okay, in decibel, if you want to calculate, okay, 38.9, approximately it is turning out to be 39 dB. Am I right? Approximately check the value, 39 dB. Approximately, okay, there's some approximation, so we'll go with option number A, matching with the option number A. Okay, I multiplied by 0.8 का एक बार शायद वो check करना पड़ेगा. I just have to recheck the calculation once dear. Okay. Yeah, multiplied by 0.8 also. Okay, so just recheck the calculations. Yeah, same answer coming up, 39. Okay. हाँ, ठीक है. So the closest option, let's correct this only. इसको 39 ही मान लेते हैं. And the correct answer is option number A. Okay, or else the closest also you match, 35 dB is that's what you can match. ठीक है, done है जी. Next question then. Next question. A paraboloidal reflector antenna is designed for operation at 3 gigahertz. Its largest aperture dimension is 20 feet. It is desired to build a scale model of this antenna with the largest aperture dimension scale to 18. So what is the largest dimension for a reflector antenna? What is the largest dimension for any reflector antenna, dear? Okay, what is the largest dimension for any reflector antenna? Is its diameter basically. That is the D, and that is what is the largest dimension here. That is equal to the diameter for a parabolic reflector. ठीक है? Now, it is designed for operation at 3 gigahertz. It is having the largest aperture dimension of 20 feet. Now, it is desired to build a scale model of this antenna with the largest aperture dimension scale to 18. Earlier, it was 20 feet. Remember the units. Okay, now it is 18 inches. Okay, at what frequency must this model be operated in order to have the same pattern? Acha, first of all, understand, in order to have what? Same pattern. Pattern se matlab hota hai radiation pattern. So, what do you want? You want the same radiation pattern. Radiation pattern depends on radiation intensity. So you should have same radiation intensity. And if you have the same radiation intensity, you have the same directive gain. So can you think with respect to directive gain? Okay, you must be thinking with respect to what? You must be thinking with respect to the directive gain. You must be thinking with respect to the directive gain. Come on. Chalo. Okay, same GD. Acha, now GD. What is this GD? This is again on paraboloid reflector. So what we have learned, GD will be given by ये वाला formula ले लेंगे. Pi lambda square by 4 pi into GD will be 4 pi AE by lambda square. Reverse लिखना है. GD will be 4 pi AE by lambda square. Okay. Lambda नहीं given है. I think frequency given है. Okay. So now because you are scaling it, okay, the dimension you are scaling, so frequency has to be changed if you want the same directive gain. What is that changed frequency? So let me write down in terms of the frequency. So 4 pi AE upon C by F whole square. Okay, so in a sense, GD is now, okay, 4 pi AE. What is AE? Pi D square by 4. वो भी note कर दिया. Okay, divided by C square by F square. तो F square को ऊपर लिख दिया. देखो, so eventually 4 to 4 cancel. I have pi square D square F square by C square. Okay, that is the GD. Okay, let's take it up on the next slide. Yeah, what it is? What is the GD turning out to be? You have pi square D square F square upon C square. Pi square D square F square by C square, and that can be written as constant. Okay, what is pi square by Q square? At least that part is constant. D square F square. Okay, now you want the same directive gain, GD1 to be equal to GD2. Okay, so that means K D1 square F1 square should be the K D2 square F2 square. K cancel hoga. What is the first diameter? 20 feet. Remember. Okay, this one is 20 feet. Achha, next one is in inches. Okay, so how much a feet is equal to? 1 feet. Remember, like the small scale you have now. What is 1 feet? 12 inches. Okay, that is the 12 inches. Okay, that is it. Sorry, 1 feet bola na, that wooden scale normally, the large one. Okay, 12 inches. Okay, that is the 12 inches. Okay, 12 inches. The wooden scale को recall करके याद रख सकते हैं हमेशा. Okay, so here, okay, it is not 20, it is 20 into 12 inches. Okay, 20 into 12. Further multiplied by, okay, F1 square. What is the first frequency? 3 gigahertz. 3 gigahertz. 3 into 10 power 9 whole square. That is equal to K cancel कर देंगे. What is the second diameter? It has been scaled to 18 inches. Okay, so writing in the inches only. 18 inches into the F2 square. Into the F2 square. सारे square तो cancel ही हो जाएंगे. Okay, so dear, what should be the value of F2? 20 into 12 is multiplied by 3. Okay, is multiplied by 3 divided by 18. And 10 power 9 for giga will be separate. Okay, for giga is going to be separate. Okay, so 36 by 2, 40. It should be 40 giga. It should be 40 giga. Option number C, just check out once. It should be the 40 giga. 3. Nahin. 36 by 18 to 40 giga. Just check out the calculations one. It is going to be 40 gigahertz. Okay, it is going to be the 40 gigahertz. 40 gigahertz. Done, Eji? Okay. So this one, good question on the paraboloidal reflector. Next question. Again, a parabolic reflector antenna used for reception of data is 1 meter in diameter, operates at 30 gigahertz. For far field distance. The far field distance, okay, Fresnel's region, related with the Fresnel and Fraunhofer region. And far field distance for any antenna is given by, okay, the distance which is greater than 2d square by lambda. Okay, 2d square by lambda, where d is the largest dimension of that particular antenna jiski baat ho rahi hai. What is the d? Largest dimension of the antenna. It is known as the largest dimension of the antenna. Okay, it is known as the largest dimension of the antenna. Largest dimension of the antenna. Okay. So chalo, let's check out what is the largest dimension of this antenna. Okay, now far field distance. So what is the minimum value of R? Okay, let's calculate minimum from which the far field distance will start. That is going to be 2 into d square. What is d? It is given to you as 1. Because for the paraboloid, largest dimension is diameter only. That is given to you as 1 clearly. And operates at frequency 30 gigahertz. So lambda is 3 into 10 power 8 divided by 30 gigahertz. 30 into 10 power 9. Okay, so this is going to become 10 power 2 bachega. Goes above 200 meter is my answer. Option number is straight away. Option number is straight away 200 meter is the very correct answer. DK ji. Option number A 200 meter is the very correct answer. 200 meter. Done hai. Done hai, done hai, done hai. Next question dear is here. Yeah. An antenna consists of 4 identical Hertzian dipole uniformly along the z-axis and polarized in the z direction. The spacing between the dipoles is lambda by 4. What is the group pattern function? What is the group pattern function? Okay. An antenna consists of 4 identical. Now, combination of antennas, array of antennas uniformly along the z-axis. Okay. Okay. This is on array. This is on antenna array. Okay, and polarized in the z direction. The spacing between the dipoles is lambda by 4. D is given. What is the group pattern function? The group pattern function is basically related with the array factor. Okay, for group factor function, what do you found? You calculate the modulus of the array factor. Okay, what is this AF? We call it as the array factor. What is this array factor? Achha, what is the important formula for the array factor then? Array factor, yeah, modulus of array factor given by the formula modulus of n xi by 2 is divided by xi by 2. Okay, modulus of n xi by 2 is divided by the xi by 2. Modulus of n xi by 2 divided by the xi by 2. Okay, but what is given here? N equal to 4. Achha, and what is xi? N is the number of antenna elements. N is the number of antenna elements. Okay. What is xi? It is given by beta d cos theta plus alpha. Beta d cos theta plus alpha. Okay, alpha is what? Okay, phase difference in the currents. Okay, beta is as always 2 pi by lambda. D is the spacing between the elements. There are n elements, but what is the spacing? And we keep it as uniform spacing. Okay, that is the spacing between the elements. D is known as the spacing between the elements. अब देखो यहाँ पे क्या given है? What else is given here? Okay, what are the things that is given here? Check करते हैं इसको. Okay, the spacing is in terms of lambda. Okay, so first let's focus on the value of xi. Okay, first let's focus on the value of xi. Okay, that is beta d cos theta plus alpha, and beta is 2 pi by lambda. Spacing is in terms of lambda, so lambda by 4 into cos theta plus alpha. What is alpha? Okay, 4 identical Hertzian dipole. I mean, we can assume that they are fed with the same current because they are totally identical. Alpha will be taken as 0 here. Okay, and lambda cancel. You have pi by 2 cos theta. You have the pi by 2 cos theta. Pi by 2 cos theta. That is the xi. Okay, that is the xi. Okay, so now what is n xi by 2? अच्छा, तो array factor पे आ जाएंगे अब. So first let us simplify. What is the modulus of array factor? It is given by modulus of n xi by 2. N का value 4 रखेंगे, तो 4 xi by 2 upon xi sin xi by 2. पहले तो इसको simplify करेंगे dear. This is how much? This is sin 2 theta, and sin 2 theta will be 2 sin theta cos theta. So 2 sin phi, 2 sin xi cos xi divided by sin xi by 2. But further, if you simplify, again this is gonna become 2, and 2 sin xi will be 2. Again sin xi by 2. Again applying the property. 2 sin xi by 2 cos xi by 2, and then there is cos xi also as well as, divided by total sin xi by 2, and sin xi by 2 will get cancelled. Okay, So total answer is going to be how much? The modulus of the array factor will be in the form of modulus 2 to the 4 sin xi by 2 cancelled. So you will only write down cos xi by 2 and cos xi term. Okay. So that should be, now what is xi? Xi is pi by 2 cos theta. So when you take xi by 2, that is going to become pi by 4 cos pi by 4 cos theta. And this is going to be cos pi by 2 cos theta. Okay, let us match the answer. 4 cos, where is that option? 4 cos pi by 4 cos theta, cos pi by 2 cos theta. It should be actually applied with modulus, but that's okay. Option number A. Option number A. Correct answer, Ankit and Chinmoy. 4 cos pi by 4 cos theta, cos pi by 2 cos theta is the array factor, group pattern function for this one. Okay, ji. Next one. In a uniform linear array, 4 isotropic radiating elements, again 4 antenna elements are given to you. So again on antenna array, they are spaced lambda by 4 apart. The progressive phase shift between the elements required for forming the main beam, okay, at 60 degree of the end fire. Main beam, okay, that is maxima. Now dear, let us note down some important points about the array factor. Okay, this array factor, okay, has the maximum value of, okay, this array factor has the maximum value of n. This array factor has the maximum value of n. Okay, and that maximum value occurs when? Okay, the maximum value of the array factor is always equal to n, and that occurs at when the n xi by 2, okay, when the n xi by 2, yeah, sorry, let me write it in terms of final xi by 2 only, when xi by 2 is equal to n pi, for n equal to 1, 2, etc., etc., etc. For n equal to any integer basically, 0, 1, 2, etc., etc., etc. Okay. Or we can say xi equal to 2n pi. Okay. So what is the principal maxima? The first maxima will occur for n equal to 0, that is xi equal to 0, and this will be known as the principal maxima. Okay. So whenever any question is concerned with forming maxima or main beam, okay, we can take the value of xi equal to 0. Okay, we can take the value of xi equal to 0. So kyunki maxima aa raha hai, we will work out with the xi equal to 0. And what is the xi is, again, let's take it as beta d cos theta plus alpha equal to 0, beta 2 pi by lambda, because d is again given in the form of lambda, into cos theta. Now theta is the direction in which you want the maximum radiation. So where do you want the maximum radiation? 60 degrees. So that is the theta. Plus alpha. That is what is the question. Na? What is the progressive phase shift between the elements? Okay, that is the alpha as I told you. Okay, so lambda cancelled. 2 pi by 4, that is pi by 2. Cos 60 degree is half. And plus alpha is 0. Simple answer, minus pi by 4. Okay, the answer turns out to be minus pi by 4. Minus pi by 4. Okay. ठीक है. See, normalized array factor is, see, we normalize the total field value, Kumar, na? Or maybe you want to ask something else. The total normalized field with respect to what? With respect to the field of a single element. That is what is the array factor basically, na? Okay. Or is that something else you are looking for? Okay, Bhaskar, I'll ask electrical faculty to conduct that. ISRO 2024 date and month we cannot say as of now, because the date for is definitely as of the current work going in ISRO, vacancies will keep coming every year now. 2023 exam is in December. Let's see when is the next year exam. Okay, but we can't fix up the month. Okay. Yes. So password for today's PDF is array. Just now we discussed the antenna array question. The password for today's PDF will be array. That will be available in the Telegram group. Array, everything in small. Okay, note down this password to access the PDF. And also guys, BYJU'S exam prep app has now the All India Open Mega Mocks available for you. All India Open Mega Mocks means they are free for all. You can participate into it, and the next All India Open Mega Mock is going to be starting from 16th December. Okay, and from the 16th December, you actually have the full gate syllabus test. Up to this time, some multiple mixed subject tests were happening. Full gate official syllabus test, 65 questions, 100 marks for 180 minutes. Right. Okay, so these are the free All India Open Mega Mocks, and because they are free, thousands of students are participating, and hence you can also participate and see your performance among thousands of students. Okay, and also if you get the result, if you get the good result in this, you can also get multiple discounts in the BYJU'S complete test series. Okay, ji. So, and not only this Mega Mocks, there are multiple practice quizzes and practice sessions available on the BYJU'S exam prep app. Okay, you can get it from Google Play Store or directly go to the link of this description of the video. There is a link, click onto it, you can download the app. Okay, and yes guys, that's it. Okay, so this was a 1 hour antenna practice session. Hope it is fruitful for you. We have, covered up many things like very important radiation resistance, then the very important questions based on directive gain, multiple questions on directive gain, jitne bhi common variety hote hain, directive gain, directivity, connecting with the efficiency, radiation efficiency, connecting with the aperture, the effective aperture area of the antenna and all those things. Antenna array पे हमने question लिया, parabolic reflector पे question लिया, and all those things. ठीक है? ठीक है जी, okay, bye bye. Thank you, stay safe and take care.